All right, it's 1:30, but I'm waiting for the doors to close, but I don't want to lose more time. So good afternoon, everyone. I'm Ida Rivera. Welcome to the NRC RIC 2025. Before we talk power uprates, thank you for coming to this session. There are some housekeeping items that I want to take care of. For attendees who would like to get into the Wi-Fi, the code is the RIC 2025. Please remember to silence your electronic devices. Also, please note that all RIC sessions are video recorded. The Q&A portion of this session will be through electronic means, so that means both for the virtual and in-person attendees. For those of you in the session room, please take a moment to scan the QR code displayed on the screen so you can have access to the Q&A portions and also for the live polling questions that we'll have during the session. For those of you joining virtually, you will find there is a box to the right on your screen with tabs for electronic Q&As, live polling questions, and feedback. Questions from the in-person and virtual participant flow into the same queue, so the questions received represents the total session audience. For those of you in the room, the slide showing the poll will include instructions for participants to text their responses so that we can see the response. In-person participants can text the code next to their choice to 22333. For those of you participating virtually, once you have logged into the virtual conference platform and joined the session, there is a tab for the live polling questions. Responses from in-person and virtual participants flow in the same queue, so polling results will reflect total responses received from the session attendees. As we close the session, you are invited to scan the feedback QR code and share any thoughts or insights you might have pertaining to these sessions or to the conference in general. If you have follow-up questions for any of the panelists, they will be available after the session outside of this ballroom. So please make your way to the exits so that we have discussions outside and leave room for the next session so that they can prepare to begin. All right, next slide. So now that we have covered all the housekeeping, let's get to talk about the power in the future, advancing reactor licensing efficiencies through a streamlined power uprates. Again, I'm Ida Rivera. I'm the Deputy Director in the Division of Operating Reactor Licensing in the Office of Nuclear Reactor Regulation. This is a technical session T4, and this session will go from 1:30 to 3 p.m. So what is power uprate? The NRC regulates the maximum power level at which commercial nuclear power plants may operate. This power level is used with other data in many licensing analyses that demonstrate the safety of the plant. NRC controls any changes to the license or technical specifications, and the licensee may only change these documents after NRC approves the licensing application. The process of increasing the maximum power level at which commercial nuclear power plants may operate is called the power uprate. We're here today to talk about the NRC staff efforts to improve the efficient licensing of power uprates. The NRC is committed to improving our reviews such that the review effort reflects the best use of resources commensurate with the safety significance and risk significance. The NRC preparation strategy for the staff review for future power uprate license amendments requests will support licensing schedules while providing reasonable assurance of public health and safety of the U.S. nuclear power facilities. Presentations in these technical sessions will highlight the NRC readiness for reviewing future power uprates applications and the NRC staff graded approach to reviewing these applications. Additionally, you will hear about the industry's perspective on efficiencies in power uprate licenses. There will be 3 live polling questions. I encourage everyone to participate in these questions, and we'll conclude the session with audience Qs and As. As you see here, we have 4 panelists for this technical session. The first panelist is Tony Nakanishi. He is the branch chief of the Plant Licensing Branch 4 in the Division of Operating Reactor Licensing in the Office of Nuclear Reactor Regulation. Tony started in the NRC in 2007 and is a technical assistant of the reactors for Commissioner Hansen. Previously, Mr. Nakanishi was Reliability and Risk Analyst in the Division of Risk Assessment and the Reactor System Engineer in the Division of Safety Systems in the Office of Nuclear Reactor Regulation. The second panelist is Vic Cusumano, who is a Deputy Director in the Division of Safety Systems in the Office of Nuclear Reactor Regulation. Vic previously acted as Deputy Division Director in the Office of Nuclear Reactor Regulation and Nuclear Security and Incidents Response. Before that, Vic was Chief of the Safety Issues Resolutions Branch and the Technical Specification Branch in the Nuclear Reactor Regulation. Vic is graduate of the NRC's Senior Executive Service Candidate Development Program. The third panelist is Al Santos, who is Director of Fuels at the Nuclear Energy Institute, leading the Industry Power Uprate Task Force and Accident Tolerant Fuels Working Group. Prior to NEI, he was the Technical Executive at the Uprate Electric Power Research Institute in the Fuel Chemistry, Low-Level Waste, and High-Level Waste Group. Prior to working at the Electric Power Research Institute, he spent 16 years at the Nuclear Regulatory Commission in various technical and leadership roles. The fourth panelist is Baris Sarikaya, who is a Principal Engineer, Boiling Water Reactor Emergent Work and Special Projects Lead at Constellation Nuclear Fuels. Prior to joining Constellation, Baris has significant experience in code and methodology development in thermohydraulics and neutronics areas, as well as commercial application of these methods. Baris also serves as the Vice Chair of the Boiling Water Reactor Owners Group Reload Analysis and Reactivity Management Committee. With that, I'm going to turn it over to Tony to start the presentation, and thank you.
Well, thank you very much, Ida, and good afternoon, everybody. Thank you so much for being here today. There's a lot of interest in power uprates today, and I'm really excited to be able to share some of the activities that the NRC has been involved with to ensure efficient licensing of power uprates to support the nation's energy needs, while, of course, maintaining focus on our core safety mission. Next slide, please. There are 2 main reasons we're here today. The first reason being we're expecting another significant bow wave of power uprate applications in the coming years. NEI recently came out with a survey that indicated about 70% of the sites are looking into 1 or more power uprates, which could equate to potentially 3 gigawatts of additional power to the grid. And this really is consistent with some of the recent pre-submittal interactions that the staff has been having with industry, which indicate about maybe 10 or so potential power uprates in the next 3 years alone. Now, the next reason really has to do with our assessment of historical data and the need to improve. So we've evaluated the data, and while the measurement uncertainty recapture power uprates have been relatively steady in terms of the resource expenditures, the resources for stretch power uprates and extended power uprates have continued to increase over time. On the timeliness side, there's less of a trend there, but the average for MUR, SPU, and EPU are about 9 months, 12 months, and 18 months, respectively. The takeaway here is we must do better, and we can do better. Next slide, please. The good news is the NRC has a vast experience with Power Uprate applications and reviews. Since 1977, the NRC has approved over 172 Power Uprates, and it added about 8 gigawatts of electricity to the grid, and that's equivalent of 8 large light water reactors. We have established processes that we could build upon with lessons learned we've gained throughout our licensing experience, including the use of core teams, better use of audits, pre-submittal meetings to increase efficient communication, and finally, the biggest, really the driver for potential improvement is our understanding of and resolution of technical issues that we've identified over the years, including things like containment accident pressure credit, steam dryer analysis, and fuel and safety analyses. The bottom line is, if the applications are within the operating envelope, then there's a lot of experience to be able to rely on for our review. Next slide, please. So, realizing the need to enhance our efficiency, we've established a Power Uprate working group in early 2024, and I might add this is before even the Advance Act was signed into law. And I want to take this opportunity to really recognize and thank the outstanding support and contribution made by the NRC's Power Uprate working group members. So the working group identified 3 main areas as part of its preliminary recommendations, including stakeholder engagement, adopting a graded approach to reviews, and targeted process improvements. We've already had 3 public meetings to discuss topics such as bundling of Power Uprate applications with other enabling changes, and some potential use of novel use of license conditions to support licensing, and finally the graded approach, which we'll continue to have more discussion. The staff is making progress in terms of developing and implementing a graded approach to review, the goal is to focus on those safety and risk significant areas of the application. And Vic Cusumano will get into more detail in this area. Finally, in terms of the targeted process improvements, we've already issued a delegation memo that would allow the director of operating reactor licensing to sign off on Power Uprates, where previously it was an NR director sign off, which would reduce the review by weeks. We continue to engage the Environmental Center of Excellence in the Office of Nuclear Material Safeguards and Security to clarify roles and responsibilities and to streamline the environmental analysis. And next slide, please. So I did want to touch on the NRC's review goals. I highlighted earlier in terms of the trends relative to the resources and schedule, and we have a lot of experience with Power Uprates. Nonetheless, the data shows that we have been increasing in terms of our review time. So we are actively focused on improving our review processes to achieve what some of the goals that we used to have, which are 6 months for MURs, 9 months for SPUs, and 12 months for EPUs. And we do plan to update the NRC Office Instruction LIC 112 for power uprates in the near term, as well as other guidance as well. Next slide, please. We're also very aware of the industry's interest in bundling power uprate applications with other changes, such as the maximum extended load line limit analysis plus application for BWRs, as well as fuel transition and cycle extensions. And we're in the process of evaluating historical data to estimate schedule and resource estimates for different bundling scenarios. We do recognize the potential significant savings in terms of schedule and resource usage, in part from being able to, for licensees to submit one set of analysis and for the NRC to review one set of analysis for reaching a reasonable assurance finding. Now, we do recommend pre-application engagements for those bundling plans to make sure the staff has advanced understanding of the licensee's plans if they do plan to bundle. Next slide, please. So in closing, I want to emphasize that the NRC is committed to efficient power uprate licensing to better support stakeholder needs. And as part of that activity, the NRC issued a regulatory issues summary soliciting some planning information from licensees on their power uprate submittals. And recognizing that it's entirely voluntary, this information will help the NRC staff plan accordingly for power uprate applications. Looking forward, we're going to continue to have additional engagements with industry, including the use of topics include, using data validation and reconciliation methodology for MURs. We'll continue our discussion on graded approach and binning and codifying that in a guidance, as well as some engagement with industry on standardized application and standard safety evaluation templates. These activities will support our activities to ensure an efficient licensing of power uprates. And with that, I will look forward to questions when the presentations are over, but I'm told that this is the time for the first polling question, so if we could go ahead and put that up. And with that, I'd like to pass the mic over to Vic Cusumano, who will talk about the graded approach.
Thank you and good afternoon. I'm Vic Cusumano. Thanks, Tony. He keeps talking about bundling. I'm pretty sure that has nothing to do with your home and auto insurance, but Csontos will talk to us a little bit more about some of the benefits and maybe challenges of that. So I'm Vic Cusumano, Deputy Director of Division of Safety Systems in NRR, and we'll be talking a little bit about the graded approach to power uprate reviews. So the NRC is committed to ensuring that our reviews reflect the best use of our resources, both ours and licensee resources, while accounting for safety and risk significance. This strategy for future power uprate license amendment requests supports licensee schedules while still providing reasonable assurance of public health and safety. The graded approach aligns with the goal that we have across NRR to streamline our technical reviews, which was also consistent with Section 505 of the Advance Act, and for those of you who've seen it, the new NRC mission statement. Next slide. So a couple of things are on this slide, Be Risk Smart and the Advance Act. So what's changed since the last series of power uprates? The last EPU was approved in 2017, and before that it was 2014. But we have completed a handful of MURs, the Measurement Uncertainty Recapture power uprates, between 2017 and 2021. And even since then, a lot has changed. NRC's got a long history of integrating risk insights into our decision making. Specifically, we consider risk insights together with other factors to better focus our attention and the licensee's attention on issues commensurate with their importance to public health and safety. One of the things that we see has changed a lot is that we're becoming more deliberate about incorporating risk into our processes, thus this graded approach we're talking about for power uprates. So we include quantitative risk information like PRA, alongside more qualitative factors such as defense in depth, safety margin, and of course our evaluation of regulatory compliance. So in addition, to become better at what we do, we've been focusing on 4 areas: developing and managing our workforce, applying risk throughout all of our decision making, even beyond technical, and generating innovative ideas, reaching out to our staff and our stakeholders for better ways to do things. And significantly in the recent time is we've been looking at new technologies and relying much more heavily on data analytics to see where we've been and have that inform where we're going. And then also on that slide, you see Be Risk Smart. The Be Risk Smart framework supports applying risk in our decision making by providing a systematic approach to making risk-informed decisions. It combines traditional concepts such as the risk triplet, risk management, the heat map, and even risk appetite into a plain language framework that gives our staff confidence as they apply risk insights into making our decisions. Next slide, please. Okay, so you see the pyramid there. We're going to talk, as Tony mentioned, about the power uprate working group's work. They issued a preliminary recommendation memo in September last year, and one of the key recommendations was the development of a risk-informed graded approach to our reviews. So the working group was looking for ways to focus our power uprate reviews on the most significant portions of the applications that come into us. This lets us evaluate the extent to which the power uprate changes impact structure, system, and components. So 3 categories or bins will be used to grade the expected level of effort commensurate with safety and risk significance, which will inform how much of our effort, both time, duration, and staff review hours, will be needed for either a minimal, moderate, or detailed comprehensive review. Bear in mind, this is our first cut at how this will work. Right? This is going to be an iterative process, and we look forward to improving as we meet with our stakeholders. I think June is the next interaction. And of course, it'll be informed periodically as we start conducting the reviews. Next slide. Just high level, the considerations for binning are based on NRC RS001, Review Standard for Extended Power Uprates, which include things like flow accelerated corrosion, accident analyses, control room ventilation, emergency core cooling. All these systems are part of that. So as we look at each of these, we're going to see, does the power uprate change our margin availability? Does it change defense in depth? Does the change push us closer to a regulatory limit? So these are the things we're going to be looking at, but the working group did identify that about 30% of the RS001 sections are amenable to a risk-informed evaluation. Next slide, please. So here's our first cut at sort of a roadmap of how we'll get there. In the first block, the staff's going to evaluate, does the power uprate change a design basis value or assumption? Does it change how NRC regulations are met? If no, then that's probably going to end up in bin 1 for a minimal review. Don't ask me to define that just yet. If the answer is yes, then we'll evaluate if that power uprate results in a significant change in margin or defense in depth or pushes very close to a regulatory limit. If the answer is no, you're probably going to be in 2 and maybe even 1. If yes, you might be moving to the next block to evaluate whether or not this change needs to be in bin 3 for a more significant review. Next slide, please. So talk a little bit about that minimal staff review in bin 1. These are areas where the power uprate is likely not going to affect systems design or operation. We could even streamline our safety evaluation in these cases. For example, maybe have a single section in the SE just listing the review areas in one table and that the staff reviewed them and determined that they're not really affected by the power uprate. Things like non-safety related plant heating, ventilation and air conditioning systems. So there's plenty of things that could end up in that minimal review category in bin 1. Next slide. Bin 2 is going to be probably a larger bin, but these are areas where we'll see a moderate staff review. These are areas that are affected by the power uprate, but unlikely to have a significant impact on safety. We don't expect the conditions to exceed design parameters for pressure, temperature, etc. And we'll be applying risk insights to determine any significant contributors to plant risk. Licensees may voluntarily provide some of this risk information to us as part of their application, which would inform our review and potentially make it easier for us to look through. That could have a positive, and by that I mean lowering impact on the resources needed to conduct our review. We'll emphasize areas that are closer to regulatory limits over areas where there is significant margin. We'll also look for large percentage changes in margin, and the staff will use their engineering judgment and experience to help decide what a large percentage would be in this case, and that will get tightened up as we do more of these. So large changes in defense in depth would also be areas we'd be looking at a little bit more emphasis in our review. Reg Guide 1174 provides some expanded guidance on this. So based on how this evaluation goes, something may end up in bin 2, or it could go back to bin 1 if there's plenty of confidence added by precedent reviews we've already done, for example. Next slide. Okay, so bin 3, areas where a detailed staff review might be expected. These are areas that are directly impacted by operations at the uprated power, and were expected to require a detailed review by the NRC staff. These categories include things that didn't screen into bin 1 and 2 by definition, and they may have significant changes in system design, analysis, or operation. We may see larger changes in margin or defense in depth, or challenges to regulatory limits. These would be more risk-significant changes, and in some cases we'd be looking for things that would deviate from an NRC-approved methodology. So in those areas, we would expand our review. Other examples might be areas where you're applying, a licensee or an applicant's applying a new or novel approach to justifying the power uprate. So those would be triggers or key things and flags that we'd be looking for. You know, for example, you might be using a code or methodology outside of the limitations and conditions, or deviating from an approved reg guide or acceptance criteria. So one other thing we'll be looking for as we dig into these more risk-significant changes would be the precedents that are cited to make sure they're justified and used appropriately, bearing in mind that just by citing a precedent for something that was approved, that by itself does not mean that the thing we're looking at will be approved. We have to see if that precedent is applicable. That certainly can positively impact our review resources needed. So these significant support systems, reactor and containment reviews, accident analyses, may fall into this category. Okay, next slide. And finally, with the graded approach, the staff findings that we need to make aren't changing. All right. The graded approach still requires us to find reasonable assurance that public health and safety are not endangered, and that there's still compliance with NRC regulations. So we're continuously working on documenting this process. Like I said, it's a bit of a work in progress, but we want to keep documenting what we're learning, both from our interactions with stakeholders, our interactions internally, and through first engagements on the first power uprates that do come in. So there'll be a draft document developed, and then we'll have public meetings to discuss this with you. Thank you very much. Those were my remarks. And no one told me I was really here as just to open for Al Csontos, but here he is.
So first things first, Ida, thank you very much for the introductions. You have the hardest named panelists.
I know.
Okay, so when I went up to go get registered, I told him my name's Al Csontos, and I gave him the spelling. He said, "How do you spell your last name?" I said, "CS," and he totally glitched. He just would not put the C in front, and he kept on using S, and then about 3 times I did. So yeah. Great job. So I think what I want to start off with is that we've been tasked by the president and the executive orders to unleash American energy. And by that, he means ensuring an abundant energy supply. And that came out just recently, okay, last couple of weeks. And we also got tasked by and directed by Congress and the president to be more efficient in our licensing, okay? And what I'm going to talk about today is how we at the industry and NRC are working together to accomplish both goals, okay, both missions. Okay, next slide. So I represent the NEI Power Uprate Task Force. I represent utilities, vendors, fuel vendors, and other research organizations that are supporting both power uprates and advanced fuel cycle extensions, okay? They provide me the strategic guidance of moving forward with the industry power uprate activities. Next slide. So as Tony mentioned, NRC has approved 172 power uprates in the past. Nearly all the plants in the United States have power uprated, but what you can see here in the upper right and upper left, for the upper right is the PWRs, and the bottom left is the BWRs. And you can see that we've had 2 units in the BWRs that have gone beyond 20%. And then also you see that most of the BWRs have done a substantial power uprate. On the PWR side, you see that there's a lot of room for growth, a lot of room for power uprates, okay? And we've also seen a couple of Swedish utilities units uprate power beyond 125%. So 20% is a number right now, and we should be thinking about how we can expand power and energy production safely, even beyond the 120% range. So what we did at NEI is we examined the NRC data, as Tony mentioned, and we identified that the schedules and costs increased by up to 7 times, okay, in terms of some power uprates reviews as time went on, as we got more knowledge. Now, what we're trying to do is prevent that going for the future, okay? We want to go and take a look at where we can get efficiencies, as well as, we talked about bundling, I'll go into that a little bit, and just talking about how we can drive some of these schedules and create these efficiencies. And we have some ideas, and that's what we worked on in these workshops. Next slide. So why uprates? We are incentivized by federal tax credits, okay? And those tax credits have yielded a lot of movement in the industry to go forward and have plant restarts, but also looking into uprates and also increased capacity through changing your fuel cycle from 18 months to 24 months for PWRs, okay? Most BWRs, except for one, is on the 2-year cycle already, okay? And so we did a survey at NEI back in 2023. This number was 50% of sites had a level of interest with about 2 gigawatts of electricity generation, okay? And in 2024, that moved to 70 and 3 gigawatts. I can tell you that I've already heard back from others who are now, that number is now also old, and when we do another survey in 25, I'm sure it's gonna increase even further, beyond 3 gigawatts, okay? Now, nearly half of the PWR fleet is looking into going forward with cycle extensions, okay, through 3 different types of advanced fuels: accident-tolerant fuels, higher enriched fuels, and also ones with extended burnups. And 3 different categories of 3 different types of transitions from the 18 to 24 months, depending upon your site, okay? And there are business cases that have established all this for each site. And what we're looking to do, though, is that to meet these strategic aspirations of these sites and to where they want to go, we're looking to the Advance Act to try to get us that efficiency working with NRC. Now, to say this, we started this effort with power uprates, advanced fuel transitions, long before the Advance Act came out, okay? We started looking into how to become more efficient in this way, okay? So the Advance Act came out really after we already started this process for months, if not years. Next slide. So we've gone back and forth with NRC on some of the improvements that we think that could be done here, okay? The first thing is that NRC did update their timeliness review goals from 9 to 6 months for MURs and 12 to 9 months for SPUs and from 18 to 12 months for the EPUs. Other areas that we started to discuss was how do we become more efficient in what Tony mentioned, bundled reviews, okay? What does bundled mean? It means sequential and combined. In the past, NRC internal guidance said you can't do sequential, meaning that one had to be relied on the other, okay? To meet our timelines of first the tax credit implementation, but also for the timelines for the business cases for the plants, it required us to be thinking outside the box in terms of how do we get that efficiency. And this is where we came up with this graded approach, improved efficiencies through these bundled reviews. And we're gonna give an update. I'm gonna give the PWR side, okay, for fuel transition plus a power uprate. And Baris down there from Constellation is gonna give you a BWR focused example looking at MER, EPU, and Mela Plus. Okay, next slide. So how do we do this and why do we see the efficiency in bundled applications? Because there are very similar analyses that we can reduce the duplication of effort, triplication of effort, by going in and doing something together to the end state of where the plant wants to be. So if a plant wants to have a 24-month fuel cycle and an EPU, which there are several, you have to do these types of analyses here, okay? Fuel transitions using these advanced fuels, accident tolerant fuels, higher enriched fuels. Higher enriched for us at LEU Plus is 5 to 10% U-235, okay? And extended burn up to go to the 24 months fuel cycles. So if a plant wants a power uprate EPU plus a fuel transition, okay, both are incentivized by the tax credits, you have these two types of analyses. They're almost identical, okay? So rather than having the staff have to review each one, okay, separately and in sequence, how about we just go to the end state of where the plant wants to be and we just do it once, okay? This, we got this back from the staff. Staff said for the spent fuel pool storage reviews, they'd rather not do it 3 times. They'd rather do it just once. And this helps NRC out with their resources and their schedules, as well as ourselves. The trick is, not all bundles are the same, okay? So there are things that are probably not worth bundling, because it's probably take the review way too long. So what we've done is we've worked it out so that during pre-submittal meetings, the utility comes in and tells NRC what they're planning to do. And then that way we document whether or not that's a good bundle to do and it's gonna save us time. Okay, because if you think about it, there are many perturbations that you can think about in terms of what you can bundle and what not, okay? Like local methods, fuel transitions, power uprates, that seems to go really well together. But if you try to do an SLR plus this, it might be too much, okay? So this is where we're working, and NRC is open to having a dialogue with the utilities on how we go forward with these bundled uprates and reviews with other activities. Next slide. So this is the plan in a nutshell, okay? We're seeing first the tax credits in 2022, then we have these workshops that we started back in January of 24, then we had the Advance Act come out, okay? And we developed a lot of efficiencies through these workshops that we started since January. And then there's this the increased enrichment, risk-informed LOCA rule that's underway right now, rulemaking with the staff, okay? Though that has a lot of benefits in terms of also reducing exemptions that are needed to go to these LEU plus fuels, okay? Right now, we have a potential for, and you're going to hear about on Thursday afternoon, there's a session looking at the advanced fuels part. And you're going to hear Southern talk about how they're going forward with the first LTAs, lead test assemblies, of greater than 5% enriched product since shipping port. Okay, they're loading that. That's a big deal. These are big deals, okay? And so what you're going to see is right now we have about 55 applications as of right now, okay, over the next 6 years, okay? What we're seeing is that with the increased enrichment rule, and if we can get a implementable risk-informed LOCA rule along with that increased enrichment rule, that you're going to see, I think, additional implementation and taking advantage of some of that additional margin later down the road. So you'll see probably 2 rounds at a minimum of uprates, okay? And so you see that's 3 gigawatts now. You could probably see about the same later. And I think this is where we're going to go to the polling, and I'm going to come back after Baris's talk to summarize everything. But I think we have a poll question that we want to share. Okay, and I'll be back in a second. Baris?
Good afternoon, everyone. My name is Baris Sarikaya. Speaking of having difficult names to pronounce, Ida, you did a great job for it, everybody. So I work at Constellation Nuclear Fuels, and in this discussion, I also represent the VWR Owners Group. Before we talk about the benefits of bundling your home and auto insurance together, let's take a look at where we are or our historical facts a little bit. I picked a case study from 2009 and 2014. I think this timeline shows how we evolve as an industry with the fuel vendors, with the utilities, with the regulator, and apply the lessons learned. I think this is a great example of it. Back in 2009, we started the 9 Mile Unit 2 power uprate project, and it took 31 months, the approval periods. I'm not talking about the implementation. There are more time on that one. We did, as Al mentioned before, everything's in sequence, sequentially. We did EPU first and Mela Plus next, and if you want to do MUR like we did in Peach Bottom, you included that as a separate in series. And if you look at the review time in terms of only the review in terms of months, that's the blue row there. It's about 4 to 5 years. But it doesn't stop with the review. We have to, once we get the approval, we have to implement that. We have to wait for the outage to make the modification. So if you really look at the calendar time, it's a lot longer than that. So we're talking about 6 to 7 years of implementation from beginning to end. And we're going to talk about what we can do in this area. 7 years of implementation increases the business risk and adds a little bit more other issues about the training, the operations, the implementation phases. But one thing that is striking to me is that we started with 31 months at 9 Mile Unit 2. All the lessons learned that we applied, we were able to reduce that time to 2 years for Peach Bottom. Now, both Tony and Vic mentioned about 18 months. Today, too, we're targeting 12 months. It's not just shortening the time. We are learning. Both Tony and Vic mentioned we've done 172 power uprates since 1997. We're not, power uprate is not a new concept to us. It's not a new concept to the fuel vendors with methodology. It's not a new concept to the industry for implementation. It's not a new concept to the regulator for review. Flow window expansions like Mela Plus is not a new concept. And then in the next slide, we'll talk about how we've gotten to MellaPlus. Similarly, MUR. So we are actively learning. We're actively incorporating the lessons learned into our submittals, implementation, operation, and review. And that's the benefit, one of the major benefits of being in this industry. So again, before we start talking about the combined license applications, let's take a look at the why we need the MellaPlus with power uprates. It's not just, it's good to have, it is real, it's nice to have, it's really needed. And then this, hopefully this slide will summarize this. Way back when we first started designing the plans, this was the representative power flow map. This is a little bit different than the PWR, so I wanted to bring it to the discussion here so that we all are looking at, have the same understanding. So on the y-axis we have the power, on the x-axis we have the flow, and we can operate within this envelope. But as we start operating, what we quickly realize that at the rated power, look at the flow window that we have. It's very tiny. That means every time I need to maneuver the plants, I need to come down in power, follow that line over there, and how do I achieve that? I insert control blades. And even though inserting control blades is a safe mode of operation, it still creates a local transient near the fuel rods. So anytime that I unnecessarily deviate from a steady state operation, I'm creating a local transient, not global level maybe, but local transient. So that's one thing that is really difficult, and in the next slide we'll talk about why other means is better than controlling with the control rods. So as we learn more and as we operate it more, we kind of figured out that we can do better than that 1% flow window. So with our fuel vendors, with our engagement with the regulator, the industry, we started thinking about how can we expand that flow window at the rated conditions so that we can control the plants with flow in a more smooth and easier way than maneuvering with the control blades. And that comes the extended load line limit analysis that gave us that. At the same time, we started thinking about, okay, if we can benefit the operations on the left side, how about on the right side? If I increase my core flow, I reduce this. Remember, this is a boiling water reactor, and we have void in the core. If I increase my core flow, I end up collapsing some of those voids. That results in better moderation. Better moderation results in reactivity insertion, controlled reactivity insertion to add. And with that, we can extend the cycle at the end of cycle where we deplete our fuel. That enables us to utilize fuel more effectively. That enables us to extend the cycle, and an unintended side benefit, it gives us, because of improved fuel utilization, less spent fuel storage requirements. As we learn more, said, okay, if we can do Ella, can we do better? Comes the maximum Ella concept. And with that, you see, we went from a 1% flow window to almost 20% flow window, 15 to 20, depending on your side. And that's how much of a flexibility we gain. While we were operating with the Mella and current power level, we learned more, and we started applying those lessons learned, comes the power uprate. But with the power uprate, even though we put more megawatts on the grid, the side impact, side effect was we still ended up having a small flow window. And now, because we learned from Ella and Mela, we know what to do. Comes the Mela Plus. Since we like acronyms a lot, so we needed to create acronyms. And then Al mentioned that we may be going beyond 120%. I think if we go beyond 120%, we need to come up with a new acronym. I believe that will be Mela Sharp. But we'll come up with some new acronym. However, you see now Mela Plus, in theory, nothing different than the concept that we developed for Mela. It's at a higher power density condition. So we learned quite a bit from, we applied the lessons learned from what we learned in the past. But as you can see, it's not just because it's faster review, it's because easier review or efficiency. There is a reason. And in the next slide, I tried to summarize some of those reasons. So it's clear that it's increased operational flexibility. It's improved flow window. We talked about it. It does enable improved capacity factor. We're talking about power uprates here, right? The gist of power uprate is to put more megawatt electric on the grid. If I don't have the flow window, and every time I need to maneuver the plant, I need to come down on the power because I have to follow that very narrow operating window, then I'm defeating my purpose. I'm reducing my capacity factor, and I cannot really put all the megawatt electric that I plan to put on the grid. This, in a sense, maximizes the benefit of power uprate. It is much less complicated to operate the plant with flow than all constantly changing sequence exchanges, the control rod patterns. It means easier, less complicated field design, core design, cycle management, plant operation, and safety analysis. On the control rod maneuvers, I want you to think a little bit about this part, because it's not just the sheer amount, the number of less control rod movements. It's going back to the earlier discussion that we had on the local transients. If I reduce the amount of local transients near my field rods, that translates into improved field reliability. Field reliability is a big concern or big ticket item for the industry. We are trying to constantly improve that because dealing with the consequences is very challenging. And our goal is to reduce the field reliability consequences as we move forward. On the far left side or right side, it's the improved fuel economy, the fuel cycle economics. If you can improve your capacity factor, if you can reduce the number of load drops that you have to manage during a cycle, you're putting more megawatt electric on the grid, and you're indeed, in a sense, maximizing the benefit of your power uprates as discussions or implementation. So, in summary, Mela Plus supports the operation of EPU power levels in this safe, effective, and efficient manner. Again, Tony, Al, and Vic mentioned 172 power uprates since 1997, 8 gigawatt electric. That's 8,000 megawatts electric plants. That's nothing. That's think about it. If we were to build 8 that size plants right now, how much that would cost? And then again, both Tony and Al mentioned that we have been operating in this condition. It's not a new concept. We know how to model, how to analyze, how to implement, how to review, and more importantly, how to safely operate these units. We've done that. We have a good record of that. So all that experience gained from the operation, I think we have a great opportunity to leverage the synergy in the analytical scope. I'm very interested in what Vic presented with the binning. Tony mentioned about the graded approach. If we can combine these concepts with the, of course, with the risk insights, incorporation of the risk insights, and with our existing understanding and basis of the methods, I think we have a great opportunity ahead of us to streamline and standardize the applications and the review process, which then leads to review efficiency. Again, if we briefly go back to the power flow map that we looked at, if I were to do an EPU analysis, this is the envelope that I have to analyze. We need to find the limiting condition and all that. If I were to do a Melaplus with EPU, it is this envelope. 80 to 90% of that envelope are the same. I can do a Melaplus EPU evaluation and cover the entire power flow map. That's one area that we need to talk maybe among ourselves to see where is the synergy, where is the boundary, what we can do within that. If you're doing an Atlas analysis for overpressure analysis, you know the impact of power uprate. You know the impact of reduced core flow. You can find the limiting condition in that envelope. If you're doing a local analysis, it's the same. So where do we move that line between the implementation? That's a topic that I think we need to have an open discussion on. So in conclusion, I think what I would like to say is that we're at a great point with everything that is going on now in the industry, in the regulatory environment, in the research, in the national labs, DOE. We can really take that 6 or 7 year implementation time, and I'm going to give this to you, Aida. You said 12, I will give you 24 with bundled applications, to 24 months or less. Al, I think this is yours.
Yeah, so, you know, the key thing here is that we're seeing these opportunities to reduce the time for these reviews. You can see here that we're doing these bundle reviews, one for the PWRs, one for the BWRs. The BWR side, by looking at that, you know, we're thinking we can get it done in 24 months. That's half the time, okay? That's a big win. And hopefully what we can do is maybe even go down and go after maybe some AI, looking at those 172 SERs, REIs, and LARs to find out what things have been done, I could say just going through it and pulling out those things that we have done multiple times that we can be at more of a checkbox review, okay? Basically, these power uprates are a bridge to the future, okay? And it is there to improve efficiencies, but also schedule and costs, making and meeting those costs and schedules. If you do that, you gain confidence, and we can move forward with advanced reactors too.
Okay. Thank you. Thank you all for great presentations, great insights. I think that, can we give them a round of applause for so we do have a number of questions that have come in, but before we go to the questions, can we go, we had a third live poll question.
Oh, that's right.
I think that we're getting the answers to the questions as well, so maybe we can take some time to see what they're telling us a little bit here. On this one, on the third one, It talks about what are the technological advancements could most improve the power uprate efficiencies. And here the results are telling us that realistic modeling assumptions and methods for plant safety assessments and licensing basis analysis might be the most important piece of that. Can we bring polling number question 1? And it talks about in the next decade, how much do we expect to see power uprates to contribute the overall increase in the power, in the nuclear energy production? And we see a moderate contribution with significant contribution as a second. So we agree that we do see power uprate being a very easy way on how we can increase power into the nation here very quickly. And then the last polling question on question number 2 is, what is the primary concern when evaluating a power uprate? With a very strong response on the reactor safety margins. Oh, and then comment number 2, the economic feasibility and the licensing and regulatory hurdles. So I think that we all agree that there is, NRC and the industry, we have to work together, and that's why we have been working since last year through these workshops, because we do want to make sure that we are providing an efficient way of power uprates for the nation and for the industry. So going down to the questions that we have received, I do have a number of questions for the panelists here. Not in any order, but I'm going to group a couple of questions. And Al, I think some of are going to you. And do you think that the U.S. supply chain is prepared to efficiently support many power uprates currently being planned? If not, what needs to be done?
So that's a good question. We need to, one of the things that we need to do is exercise the supply chain so that we can then get more contracts in place and move forward, okay? These are where the power uprates come in. There's an incentive. There's also an incentive within the tax credits for manufacturers to get tax credits to develop the supply chain as well. And so the challenges of supply chain, I have heard that from our utility colleagues, there is a long line of components, and I know that the gas plants out there have about a 5 to 6 year lead time on some of their plants' components. That's just the gas plants. And nuclear is another level above that in terms of QA and such, and a smaller supply base. And so yes, it is a big challenge for large components, but there are some other things that the increased enrichment rule and the risk-informed local rule, plus changes in some reg guides, will give some analytical space to also get uprates. But there's different types of uprates, but the ones that rely on big components, yes, the supply chain, and we have a project right now working with INL and Svetlana Lawrence in the audience, looking at domestic content. As part of the tax credits, they talked about getting another 10% on your tax credits for the investment tax credits that are 48E, okay? And in that one, what you have is a 10% adder if you can show that your component is majority fabricated here in the United States. And that goes along with also some of these other executive orders and what's going on right now in politics space. So right now, manufacturing of these large components in the supply chain is a concern. So.
And there is a similar question, but, well, related but not similar. It's another area where could be some impacts on why some power uprates have not come through historically is related to, is there any significant difference in the VWR fleet versus the PWR fleet in the total number of power uprates to date? More specifically, does the neutron fluence impact on the aging of the reactor vessel with Power Uprate become limiting such that the EPUs are not feasible for the PWRs?
So I think plant aging is a consideration, and I think plants take into that consideration during the time where they plan on their strategic aspirations and their strategic plans for their upgrades at their plants tied to SLR. And also, when you think about it, when you go in for a subsequent license renewal, do you do that before or after you do your upgrade? These are the types of things that a plant has to consider. And of course, aging of the reactor components is a major point of that, not just the pressure vessel, but other components like large ones like steam generators and other things as well. The difference between the Bs and the Ps, the Bs did go do a lot of upgrades on most of their sites. And I think the Ps, I think that maybe there's a time element as well with that, because we also had this time back in the late 2010s that there was just the industry was not in a good state, and so uprates had been stopped in that time. But I think that now looking at the cost effectiveness of these power uprates and compared to natural gas, compared to new reactors, the cost is quite. It's much more feasible now for power uprates compared to natural gas plants. And it's on the same kind of order of magnitude as natural gas plant costs when you take a look at LCO and LCOE and everything. I don't want to go into it, but it's just there's reasons why now it's been reevaluated with the tax credits and also with what's going on with the surge in the demand in the United States for AI and other data centers.
Thank you. Vic, this one goes to you. Do you anticipate that the concept of binning for power uprate review area combines with other suggestions in the staff recommendations related to conducting power uprate inspections during the review of a power uprate license amendment could have a net effect in reducing the volume of information a licensee submits with the application? For example, could bin 1 areas be dispositioned solely by inspections? So.
Okay, I think I understood that, and especially for bin 1, we're looking at anything we can rely on to give us confidence that the scope of our review can in fact be reduced. And I've not specifically considered inspections as part of that, but I don't see any reason why inspections could not be a factor if they give us the information we need, similar to audits, and perhaps combining the two.
Can I add something to that?
Yeah, you can. Yeah.
I think this is where AI can come in too.
Yeah.
Okay, because I think that we have 172 of these over time. We have metrics that we can evaluate to. Before we go off and do other things, let's take a look at what we've done in the past and then make those metrics and mine the data using AI to find out what we've done similarly, maybe 100 times. And then we make those and put those into the bins. If we've done something 100 times, that's easy, bin 1, and it's a simple one. If it's more complicated and it took a lot of time in past reviews, then it's a bin 3.
I think using AI to review the work we've already done in the past, to me, is nothing more than a really enhanced precedent search, right? And we always rely on precedents. This is just a better, faster, smarter way to rely on precedent.
Yeah, I just wanted to, I appreciate you bringing AI up because the working group actually just recently, this is kind of late breaking, but we did reach out to our colleagues in OCIO to explore ways to look at, how AI could inform our regulatory approaches and to be efficient in our reviews and so forth. So certainly more to come, but we're looking into different use cases to try to see what makes sense for power uprate, and really, frankly, it's something that's really generic to any kind of licensing technical review. So.
Yep. Perfect. Thank you. These are for Vic, for you. When you talk about regulatory limits, what do you mean?
At this point, we're considering, and any of you guys who are want to jump in as well. But, regulatory limits would be the limits on pressure, temperature, peak clad temperature, things like that. That's what I think of when I think of how close are you getting to the limit on, by regulation of where you can operate your plant.
Perfect. And then another question we just got is where can we access, or you all can access, the regulatory issues summary on power operates?
Yeah, thank you for the question. I think the easiest way to access things these days is to just Google it, and you could you could actually Google NRC power uprate risks, and it should come up. And on a related note, we've been trying to put more information on the website, NRC website, related to power uprate readiness. So so that's also available, and you could find some of the more details that Vic and I have been discussing, some of the public meeting information and some of the early improvements that we've been making, like core team charter and so forth. So that's all available on the NRC webpage. But Googling is probably the best way to just get there.
Yeah. And
So I just wanted to, I had it on my last slide and just ran over time, but the industry is going to be responding to the RIS, NRC RIS, and you're going to get a lot of proprietary information as well, direct from the utilities, and then some non-proprietary from us. Yeah. And so, and the reason why it's proprietary is that you have a lot of these that you have to negotiate with your PUCs and others, and so this is just something that, for business reasons, they're going to keep it and send it under affidavit.
Appreciate that. We're looking forward to those responses. And so, Tony, you talked about the drivers of why we're here, and historical drivers that have increased the review resources over time. Can you elaborate what caused that and why we saw that in the past?
Yeah, thank you for the question. So I mentioned a couple of large technical areas like fuel and safety analyses, steam dryers, containment accident pressure credit and so forth. But we've been digging into the data, right? And there's really kind of two sets of data, like early 2000s to kind of after 2000s. And if you look at things like, even like the number of reviewers that were involved and, sort of the number of SCR pages, safety evaluation report pages, it's really kind of grown over time. Now, there's a lot of history with power uprates. There's been, like, for example, OIG audits that have recommended certain changes in terms of documenting staff evaluations. ACRS over time had some feedback to that effect as well. But I think over time we've sort of gone into maybe more detail than we might need in terms of making that reasonable assurance finding. So it's really a combined. There's valid technical issues that we've had to identify and evaluate, but I think we're at a point where we know how to address those. So really optimistic in terms of how we could review these applications, as long as it's sort of within the envelope of the current operating fleet.
Yeah. All right, thank you. And so Baris mentioned that a goal for a combined bin application for Melaplast and EPU could be 24 months. I want to make sure, because we did get a question about what is the revised schedule goal for a stretch and EPU reviews. And so I think that the goals are for specific applications that are coming in the same way that we saw them in the past. This is the goal that Tony was talking about, the 6, 9, and 12 months for MUR, SPU, and EPU. But for the bundle, we're still working with the industry to better understand what are those applications going to look like, what are those bundles really coming in for, so that we can have a better understanding and work with to provide a more specific or more goal setting for applications that are coming in bundled. I think that the upcoming workshops that Tony mentioned later this summer that we're planned, we don't have a date yet for those, but we're planning to have them in the summer where we can start talking about standard applications and also the binning efforts. I think combining those two efforts will provide us a better goal setting for what the industry can expect a license review to take for those But I believe that I don't want to say completely confirmed, but I think 24 months might be a starting point where we probably will then move around and see what comes out. Baris.
I agree that the goal is to improve the efficiency from the 6 or 7 years to what we can do here in a much less time. And then that 24-month cycle or duration is an estimate based on what we've seen in Tony's presentation, that if we want to combine, we don't expect that to be a linear increase, because there is potentially a impact of the competing phenomena in different areas that we need to address, but eventually we're going to end up having to perform this in a much shorter time frame, even in combined applications. Just like what we've done in the power uprates, we started with 3 years, 2 years schedules to 18 months to 12 months. That 24 months is a target for now, but as we move in that direction, as we learn more, as we become more efficient in what we're doing, even that number can be further improved in time.
Yeah, I think ultimately applicants come in, pre-submittal meeting, discuss their bundles, discuss what the similarities are, and then get from NRC staff what the potential time frame is. But the one thing we got to watch for, and one of the things we want to make sure we do, is create that efficiency. So looking at metrics, looking at, the more we know, the better it should get, okay, in terms of efficiency, and not the other way around. And I think that's where we're going to be. I think we need to keep an eye on the metrics for these reviews and looking at how similar, like an SPU and EPU, how similar they really are. And then we go forward to see what the realistic time frame is.
Agreed. Thank you.
Ida, maybe one more thing.
Yeah, go ahead.
If I may. And I think, to Ida's and Tony's point, it is important to have an open dialogue in workshops, in white papers, in maybe even owners group recommendations, the templates, the roadmaps. If we work towards those, and if we can bring ourselves more standardized applications, because we're going into a new envelope, new operating regime now, that is going to be a little bit challenging at the beginning. But if we do our own due diligence to make it as standardized as possible, eliminate the uncertainty in applications, eliminate the unpredictability in applications, I think that will be the best that we can do to ourselves, both in terms of review, planning, and also implementation.
Agreed. And we did get a question here about who can participate in the summer workshops. So these will be public meetings, so we will notice them as any other public meeting, and so anyone can participate and attend as part of those workshops. With that, I think that this is the end of our session here. I appreciate everybody attending this session, providing meaningful questions, participating through the polling questions. I think we all learn. We have a ton of work ahead of us, but we are very, very excited of the progress we have made and the work that we have in front of us to make sure that we provide the additional power to the nation that is necessary. So Thank you for coming, and enjoy the rest of the RIC, and please provide any feedback as you go in the QR code. Thank you.